this lecture, we will discuss the singular point of a function fz. Now, what is the statement, the definition of a singular point? So, first, a point z equal to z0 is said to be singular point of a function fz if function fz, if f of z is not analytic at z equal to z0. So remember that at any point where function is not analytic, that point is called a singular point. For example, if I take the example 1 by z, so z equal to 0 is the singular point. If I take the function z minus 1 into z minus 2, so singular point are 1 and 2, because function is not analytic at the point 1 and function is not analytic at the point 2. Now, if I take the function e raised to power z, so it has no singular point because it is a analytic function. Similarly, if I take tan of z, so this can be written as sine of z over cos of z. So singular point are those at which cos of z equal to 0. So cos of z equal to 0 implies z is equal to 2n plus 1 into pi by 2, where n belongs to integer. So all of these are singular points. So this is a function which has infinite many singular points. So remember that this is a function which has infinite many singular points. Similarly, cot of z. So again it has infinite many singular points. Similarly, function 1 by n. So 1 by we can use it as a sine of 1 by z. This is. So we can discuss many functions which has singular points. Now after the singular point, there are two kind of singularities. One is isolated and second is non-isolated. So first we divide these two parts. So one is isolated. One is isolated singular point and second is non-isolated. One is isolated singular point and second is non-isolated singularities. So first I discuss the isolated singular point. So a point, suppose a point z equal to z0. This is a isolated singular point, isolated singular point of a function fz. So if it is an isolated singular point of function fz, if it satisfies two conditions. Condition number 1 A, fz is not analytic, not analytic at z equal to z naught. So condition number 1, f of z is not analytic at the point z equal to z naught. Condition number 2, but f of z is analytic in deleted neighborhood of z naught. So this is analytic in deleted neighborhood of z naught. What is deleted neighborhood? So this is a 0 less than modulus of z minus z naught, and this is a radius sum delta. So this is a deleted neighborhood of z naught. Now first understand the isolated singularity. Now if we have this is some point z naught, if this point is isolated singular point of function fz, so number 1, fz is not analytic at this point, number 1. But fz is analytic in its neighborhood, in its deleted neighborhood. Deleted neighborhood means, so it is a all point excluding z naught. Z naught ਨੂੰ ਛੱਡ ਕੇ ਬਾਕੀ ਸਾਰੇ ਪੁਆਇੰਟ ਇਸ ਨੇਬਰਹੁੱਡ ਦੇ ਵਿੱਚ ਜਿਹੜੇ ਹੋਣਗੇ ਉਹਨਾਂ ਨੂੰ ਅਸੀਂ ਡਿਲੀਟਡ ਨੇਬਰਹੁੱਡ ਕਵਾਂਗੇ। तो साडे कोल आइसोलेटेड सिंगुलर पॉइंट क्या होया कि अगर फंक्शन z नॉट जिहड़ा है वो साडे कोल फंक्शन इहदा आइसोलेटेड सिंगुलर पॉइंट कदों होएगा, नंबर 1 z नॉट जिहड़ा है इट इज़ ए सिंगुलर पॉइंट ऑफ fz होवे, मतलब fz इस रेड पॉइंट दे उत्ते एनालिटिक नहीं होएगा, पर बाकी सारे पॉइंटां ते उत्ते फंक्शन एनालिटिक हुंदा तां इट इज़ ए कॉल्ड ए isolated singular point of a function fz. And second is non-isolated. So in non-isolated, the function is not analytic at this point, and also there exists at least one point in its neighborhood at which it is again not analytic. So that is called a non-isolated singular point, the non-isolated singular point. Now what is the definition of non-isolated singular point? So a point z equal to z naught, which is called non-isolated singular point of a function fz. So it is a non-isolated singular point of a function fz if z equal to z naught is a singular point, if z equal to z naught is singularity of function fz, number 1. Number 2, and there exists at least one singularity one singularity of function fz in deleted neighborhood of z naught, in deleted neighborhood of z naught. So I repeat once again. So first is a singularity. So this is z equal to z naught. This is a singular point of function fz, right? It means f of z is not analytic at z equal to z naught. Now it has two parts. One is isolated mean kalla, and second is non-isolated, यानी ਇਹਦੇ ਨਾਲ ਹੋਰ ਵੀ ਕੋਈ ਸਿੰਗੂਲਰ ਪੁਆਇੰਟ ਹੈ। ਸੋ ਡੈਫੀਨੇਸ਼ਨ ਦੇ ਨਾਮ ਤੋਂ ਹੀ ਆਪਾਂ ਸਮਝ ਸਕਦੇ ਹਾਂ ਆਈਸੋਲੇਟਡ ਸਿੰਗੂਲਰ ਪੁਆਇੰਟ ਮੀਨ ਕੱਲਾ ਸਿੰਗੂਲਰ ਪੁਆਇੰਟ, ਨॉन ਆਈਸੋਲੇਟਡ ਮੀਨ ਇੱਕ ਤੋਂ ਜ਼ਿਆਦਾ ਸਿੰਗੂਲਰ ਪੁਆਇੰਟ ਹੋਣਗੇ। ਸੋ व्हाट इज डेफिनेशन ऑफ आइसोलेटेड सिंगुलर पॉइंट? अगर आ साडे कोल आइसोलेटेड सिंगुलर पॉइंट है, सो असी ਇਹਦੇ अराउंड कोई डिलीटेड नेबरहुड ले ली। डिलीटेड नेबरहुड मीन्स नेबरहुड excluding the point z naught. If the function is analytic at every point other than z naught, if function is analytic at every point other than z naught, or we can say that z naught is only singular point of fz, then it is called a isolated singular point. On other side, if this z naught is some singular point of fz, if there exists some another point which is also singularity of fz, then it is called a non-isolated singularity. So that is a different. If it is a singular point, then isolated. If it has not single, so it is a non-isolated singularity. So this is very important definition, so that we will use in many other questions. Now first, for example, so we will understand the concept by example. So this is a z plus 2 over z minus 1, z plus minus 2, again z plus 3. So this is a function, z minus 3, z plus 3. Now this has three singularities. These functions have z equal to 1, 2 and minus 3. So this function has three singularities. Singularity, right? This function has three singular point, 1, 2, minus 3. Now check whether it is a isolated or non-isolated. Now if it is a two-dimensional space, so first I check the point 1. So this is a origin, this is a 1, this is a 2, and here Suppose it is a minus 3. It is a minus 3. Now, at this point is a singular point of function fz. Now, if I take any deleted neighborhood of 1, so we check that at other point in deleted neighborhood the function is analytic. It means this is a isolated singular point. This is a isolated singular point. Similarly, in case of 2, similarly in case of 3, it means 1, 2 and minus 3 are isolated singular point. Isolated singular point. So my aim is only check the other singularity in the deleted neighborhood, not any other place, but only in the deleted neighborhood. Now, second example. If I take a function fz which is equal to sine 1 by sine of pi by z. So, first, what are the singular point at which sine of phi z equal to 0? So, singularity of fz can be defined by sine of pi of z is equal to 0. So, this will be 0 when sine n pi. So, it means z is equal to 1 by n. What is n? N belongs to integer. So, from this pi by z is equal to n pi. So, this pi cancel with this. So, z equal to 1n. So, don't confuse. So, this is a simple calculation, z equal to 1 by n. Now, all of these are singular point of function fz. So, these are infinite points because n belongs to integer. So, all of these are singular point. Also, we can write it as plus minus 1 by n, and n belongs to 1, 2, 3, so on up to this values. So, at 0 this value is infinity, right? So, this is a not integer. So, z minus 0 because this is a, we are finding the finite singular points. Now, z equal to plus minus 1 by n, n is running from 1 to and so on. Now, check the singularities. Now, if this is our straight line, so this point is origin. If this point is origin, suppose this is a 1 and this is a minus 1. So, when we substitute n equal to 1, so this point, then n equal to 2, so this is a 1 by 2 point, then 1, 3, so 1 by 3, then 1 by 4, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9, continue. When n approaches to infinity, then it approaches to 0. Similarly, in this case, this is converging to started from minus 1, and this is converging to this point 0. Now, what is 0? 0 is a singular point, but in its deleted neighborhood, it has many other point at which function is not analytic. It means it is a non-isolated singular point. So here Z equal to 0, which is a non-isolated singular point, non-isolated singular point of function fz, because in the neighborhood of 0, in the neighborhood of origin, there are infinite many points, isolated points. That's why it is a non-isolated singularities. Now, we will discuss the third example. For example, this function fz, which is equal to log of z, this values. Now, this has again non-isolated singular point at z0. This function again has non-isolated singularity at z equal to 0. So it is again why? Because every point on negative real axis including z equal to 0, it has at z0, and every point and every point on negative real axis, negative real axis including z equal to 0. So all of these are non-isolated singular point. Now, next we will discuss the example f of z, so which is equal to 1 by sine of pi of z, right? So to check the singularity, I will take sine pi z equal to 0. It implies pi z equal to n pi. It implies z is equal to n, and n is integer. N is 0, 1, 2, -1, -2, and so on. So n is integer. So also I can write it as z is equal to plus minus n, where n is 1, 2, so on up to this, and also 0, z equal to 0. So all of these are isolated singular point. All of these are isolated singular point. Isolated singular point. Check that. Now, suppose this is some real line. This is some real line. This is some origin. So 1, 2, 3, so on. -1, -2, -3. Now, these are the singular point of the given function that we find out. Okay, these are the singular point. Now check that. Now at this place, if I take the deleted neighborhood, now function is not analytic at this point, but it is analytic in its deleted neighborhood. So it means 0 is isolated singular point. Similarly, 1 is isolated singular point. Similarly, 2 is isolated singular point. 3 is isolated singular point. So all these point 0, plus minus 1, plus minus 2, plus minus 3, and so on are isolated singular point. Isolated singular point of a function fz. Of a function fz. So that make the difference isolated singular point and non-isolated singular point. So I repeat once again at the end of this lecture. Now singular point where function is not analytic. Now this is a some singular point z0 where function is not analytic. Now if I take a some deleted neighborhood, so if in the deleted neighborhood the function is analytic, there is no other singularity in the deleted neighborhood, then it is called isolated singular point. If there exists some another singular point in its neighborhood, then it is called a non-isolated singular point. Non-isolated singular point. So this is very helpful for a competitive exam. So at which we want to find out whether it is a isolated singular point or it is a non-isolated singular point.